Okay everybody, welcome to tutorial 6. We are going to talk in this occasion about Boolean curves. Well, sometimes it's necessary to do many splits in order to get some regions of our curve. So in that case, instead of using the split option, we will use the Boolean curve. So let's see how it works. Well, basically, you don't have to do this. You just have to pay attention until we actually start developing our project. So Boolean curves is basically taking out the region or the regions that you need from the intersection of two curves. So I'm going to make two circles, any size, and I'm going to intersect them. Okay. As a matter of fact, I'm going to get 3 circles, and I'm going to intersect them also. Okay, so I have 3 circles, and now I have all these curves intersected, and actually you form different regions with the intersection of those circles. What we do is that we go to Curve Tools, we click on Curve Boolean. Now, Curve Boolean will ask us what are the curves that we actually want to look at, or we want to intersect, the ones that we want to take in account. Okay, so in this case, something that you want to do is delete. Where it says delete input, you should have all. Okay, because afterwards that you select the region, you want to delete all the inputs. So the curves that I want to select are the 3 curves. Okay, now I'm going to press enter, and it says click inside regions to keep. Okay, what are the regions that I want to keep? So if I click over here, I'm going to keep this region. If I click here, I'm going to keep this region, here, this region. Or if I wish to keep these 3 regions, okay, I click enter, and then I'll have my curves that I want. Okay. So basically that's what you want to do in order to keep some of the regions. Okay? So we're going to do it one more time to see if we understand. So select the curves. Let's say I'm going to select only these 2 curves. Okay? And then I'm going to select the regions that I want to keep. Say I want to keep these 2 regions. I could actually keep those. Or I want to keep the region inside. Okay? Or I want to keep, if I click outside, I'll keep everything that's inside, okay? So if I click out, I'll keep the region that is surrounded. If I click inside, I will be determined by the ones that I have, okay? So it's basically a way of getting different regions, okay? So I click enter, and now I have the region that I want to get. Okay, so this is a very helpful tool for the project that we are going to develop, because right now we are going to create a gear. Okay, we're going to go to File, we're going to click on New, and we are going to select Large Objects Millimeters. Okay, we're going to start with the Large Objects Millimeters. Okay. Large objects millimeters, we are going to develop our gears on the top view. That is very important. Now, the basics of gears. There's a huge theory about gears. Like there are formulas, there is a mathematical expression and equations in order to find out the different parts of a gear. Okay, in mechanics and also in physics. But we are going to dedicate and focus on how to develop those gears very simply on Rhinoceros with some basic terms. So every gear, let's click on standard, let's go back to standard, and every gear has 3 major sections. Okay? The first section is going to be the addendum circle. The addendum circle, it's the circle that going to be the outer circle of the gear, so we're up to where the teeth reach. Okay, so we have the addendum circle. In this case, the addendum circle that I'm going to create is going to be a diameter of 10 millimeters. Okay? So I have the addendum circle. The second part of this gear is the dendum circle. The dendum circle is where the teeth enters, like all the way. That would be the circle that reaches on the bottom part. So in this case, I'm going to say that that is 8. So I have the addendum circle, which is the outer circle, and the dendum circle. Now there is a pitch circle. The pitch circle goes in between these two circles. Now the pitch circle is going to determine a bunch of things of our gears. Okay, so we have the pitch circle, which is going to go right in the middle. Okay, it's an imaginary line that is going to divide the teeth, and that is kind of like all the workload of the gear goes on, and it's very important. For our design, let's just stick, and that's something the pitch circle has to do with a lot when you're creating or meeting gears, okay, which you will probably develop later on. But for now, let's just stick to these two. Now, another important thing about gears is the number of teeth. Okay, the number of teeth is the amount of teeth that the gear has, and that is a relationship, or it's a ratio between the MOD and PCD of the gear. Okay, for that you also will find equations. Okay, so we have many MODs like 0.2, 0.4 for metric gears. Okay, what we're going to develop here is a spur gear. Okay, just so you know, this is a spur gear. Now the number of teeth in standard forms, like you can look at standard gears, the number of teeth usually starts at 15. Okay, 15 gears, that 15 teeth. Okay, so the basic number is probably 15 and up. Okay, so you can start creating your gears starting at 15 teeth, and depending on the size of your gear is what you need to develop. Okay. Okay, so now let's develop a star, and a star is here on polygons. Make a polygon, and I'm going to click on number of sides. So I'm going to say that it's 15 teeth. I click here, and I'm going to go 1 millimeter outside the dendum circle, click, and go 1 millimeter below or inside the addendum circle. So we have the addendum and the addendum circle. Okay, I'm going to click here, and now I'm going to use the curve Boolean. I'm going to go to curve, select curve Boolean, and I'm going to select these two curves, okay, the outer curves, and press enter, and I want to keep the inside region. So if I click inside, I can see the one that is the one that I need. And I'm going to press enter, okay, and I delete it. I want to make sure that I deleted the inputs. Okay. Now I'm going to do it one more time. Click on curve Boolean. I'm going to select the two lines, and press enter. And in this case, I don't want to keep the inside region. The inside region doesn't work. Okay, this is not the gear. In the other case, I need the outside region. This is the one that I need. Okay, I'm going to press enter, and here I have my gear. Okay, so this is the gear that I want. I make sure that I have the dendum circle, and so this is the outer circle of the gear, and I have the inner circle of the gear, or the dendum circle. Okay, now this configuration here is the one that we can actually calculate using equations. What is the thickness of the gear, the thickness, and what is the pitch, okay, the imaginary line. Okay, so that is extremely important. So now let's extrude our gear. Okay, so let's now extrude our gear. Let's go to solid, extrude curve straight, and I'm selecting my curve, and it's pretty much between 3 and 4 millimeters. We can extrude it, okay? Okay, so we have our gear. Okay, beforehand, it is a good option to make our axle. So what I'm going to do is I'm going to create a circle, which is going to be our axle, and basically our axle is around 3 or 5 millimeters. Let's say 5, that's too big, so let's go back and let's make it 3 millimeters, and this is going to be our axle. So I'm going to extrude this 2 curves about 3 millimeters. And here I have a created gear. Okay? So, basically what you need in order to create some gears without taking into account the pitch circle or taking into account the MOD, okay, of the number of teeth and everything, it's pretty much understanding the addendum and the addendum circle. So the addendum is the outer circle and the addendum is the inner circle. So that's pretty much what we need to do. Okay? Okay, now it's your turn. Now for this activity you must design 2 gears. Okay? So you have 2 gears and they have different widths. Okay? They pretty much have the same pitch, the circular pitch that we developed. Okay, 1 millimeter above the addendum line and 1 millimeter below the addendum line. So it's the same for all the gears that we will create, because we are not designing the teeth, okay, of our gears. So it's basically the same one. As you can see here, this is not an accurate configuration for a gear, although this is the way that you can actually design gears on rhinoceros. This is something that when they meet, okay, when the 2 gears meet, you should make sure that the addendum line goes over here and it's tangent to the other one. Okay, so right now these 2 gears wouldn't be like accurate for building, but we can actually make them on 3D. So here are the different measurements. Here you have all the measurements of each of the addendum and addendum lines, and of course the axles. The axles are a little bit different. This axle is it's a radius of 4, and this axle is a radius of 2.63. And remember to work on large objects, millimeters, in order to do this activity. Okay, so good luck.